Section 6.3, we're doing more counting. It's called Basic Counting Principles. So again, we're wanting to figure out how many elements are in a data set, and it's not always simple to just count the number of elements. So as things get more complicated, we want some better methods to count large sets. And in section 6.2, we have the inclusion-exclusion principle that helped us to count the number of elements in a union of two sets. And in section 6.3, we're going to get some more methods to help us further. All right, so a teenager is asking how many different outfits she could put together if she has 2 skirts and 3 shirts. So I'm just going to kind of list out all of the different ways that she could make outfits, different outfits from these options. And just to simplify things, let's say that she's got a black skirt and a white skirt. And then let's just say that her shirts are red, blue, and yellow. So she could pair the black skirt with the red shirt, with the blue shirt, and with the yellow shirt. Okay, so there's 3 outfits. And then she could pair all 3 of these shirts with the white skirt. So she could pair the white skirt with the red shirt, the white skirt with the blue shirt, and the white skirt with the yellow shirt. So we can see we've got a total of 1, 2, 3, 4, 5, 6 different outfits that she could make. So she's got 2 skirts and 3 shirts. And she can get a total of 6 different outfits. And we could do this for any 2 events that are happening independently. So maybe you're picking one thing and then you pick another thing. You could always create like this first method is called tree diagram, where you're listing out all of the options. But you'll start to notice the pattern here is that we can just multiply the number of ways that we could do each thing. So in this case, we could multiply the number of ways we could pick a skirt with the number of ways we could pick a shirt, and we would get the total number of options. This is called the multiplication principle. So anytime you've got 2 independent events, so one thing is happening and another thing is happening. So I'm picking a skirt and a shirt. In the next example, we're picking a manager and an assistant manager. Then we can use the multiplication rule and multiply the number of ways that we could do each thing. So as the problems get more complicated and there are more and more options, you don't have to use the tree diagram or make a list of all of the possibilities. We can use the multiplication rule. So here in this example, the store has 2 open positions. They need a manager and an assistant manager. And they have 3 choices for manager and 4 choices for assistant manager. So we want to see how many total ways could they fill these 2 positions. And using the tree, we could say, so there's 3 people that could be the manager. And then there's 4 different people that could be assistant managers. So each of these managers could be paired with 4 different assistants. And we could count up all of these options and get the total. But we saw in the last example that we can use the multiplication rule. So we can just multiply the 3 options for manager times the 4 options for assistant manager to get a total of 12 different ways that we could fill these positions. And if we counted them all up, it's also 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different options. All right, in this example, we are picking a card out of a deck of cards. And it looks like in this example, we just need to know the total number of cards in a deck, and they tell us that. But there's a problem in the homework where you need to know how many cards of each suit. And in the textbook, there is a nice little picture with a list of all the cards in a deck of cards. So that could help you if you're needing to count up the number cards of each suit. So like how many diamonds are there? You got the ace, and then you got 2 through 10. You got a jack, a queen, and a king. So I think that's a total of 13 cards in each suit. We don't need that for this one, but you're going to need that later. In this problem, we're just picking one card out of the deck. Okay, so Jane is picking first. And if Jane's just picking one card out of 52, then there's 52 different cards that she could pick. And then Joe is picking next. But Jane did not put her card back. So now there are only 51 cards that Joe could choose from. So Joe only has 51 options for the card that he's going to pick. We're going to use the multiplication rule, and we're going to multiply these two. So we're multiplying 52 times 51. So 52 times 51 is 2,652. So the number of different ways that they can select these two cards is 2,652. All right, in this example, Rhonda plans to buy a hybrid car. The Temple dealer has 15 hybrids in stock, and the Austin dealer has 23 in stock. How many choices does Rhonda have if she buys a hybrid from one of these dealers? If we think about what's going on here, it may seem kind of obvious that, she's got 15 choices at one spot, 23 choices in the other. So the total there would be 38 choices. And that is the answer. But I wanted to point out here that we have to pay attention to what the question says and the situation that's happening, that we're not always going to multiply to get the number of choices. In this case, because she's only going to buy a car from one place or the other, then we would add. So there's also an addition, and we use the addition rule if we are counting sets that have nothing in common. So there's no overlap between our two situations or two events. So here, because she's buying a car from one place or the other, she's not going to buy a car from both. There's no overlap. So here we're using the addition, and we're just adding 15 plus 23 to get a total of 38 choices. In the next example, I'm going to have to do a combination of the multiplication rule and the addition. Next, let's see how many different ways we can arrange 3 science books and 2 history books on a shelf if we want to keep each subject together. Okay, this example has a little bit more going on, a little more particular than the other situations. So we can't just multiply 3 science books times 2 history books because we have a little bit more constraints on how to arrange them. So let's think about the different ways that we could do this. So there's 2 ways that we could arrange the subjects. We could put science first, or on the left, and then we could put the history books next. Or we could do it the other way around. We could start with the history books and then put the science books in. So let's count the number of ways that the books could be arranged with each of these options. So if I put the science books first, how many ways could I do that? So we got our bookshelf, and we're putting 5 books, a total of 5 books on this shelf. So in the first case, if I put the science books first and the history books second, so first I'm going to put science first. There are 3 science books, so my very first spot, I have 3 choices of science books that I can put there. After I put that book down, I've got 2 science books left. So in the next spot, I want to put a science book, but there are only 2 options now. Okay, so now I have used up 2 of my science books, and there's only 1 left. So in the third spot, there's only 1 book that could go there because it has to be a science book. So now that's all of my science books. And next, I'm going to put the history books, and I have 2 history books. So in this next spot, I've got 2 options. Either one of the history books could go next. And then once I've used up that history book, I only have one book left, so there's only one thing that could go in the last spot. Okay, so I would multiply all these together to figure out how many ways I could do this. So 3 times 2 times 1 times 2 times 1 is 12. So 12 ways that I could put the science books first. All right, so now if I put the history books first, still a total of 5 books. I want to start with the history book, and I have 2 history books. So there's two choices for this first spot. Okay, so that's the 2 history books I'm starting with. Now I've put one of the history books on the shelf, so there's only one left. It's only one thing that could go here. Okay, those are my history books. Now I'm going to start placing in the science books, and I've got 3 science books. So in my very next spot, there's 3 different choices of what could go there. Now I've used up one of my science books and I only have 2 left, so 2 options for this spot. There goes another science book, so there's only 1 book left to go in this last spot. And then I would multiply all of these together to figure out how many ways could I put this history books first. And again, 2 times 1 times 3 times 2 times 1 is 12. But the total number of ways that I could place these books would be these 2 together. So I can either put science first or put history first. And I could do each of those things 12 ways. So I can arrange these books a total of 24 ways. There's a total of 24 arrangements.